Hello folks, welcome to tonight's vidcast. I seem to be yet again having technical difficulties with my camera. Well, that's lovely. Thank you for joining us. Tonight, I'm going to be talking about the audio pipeline. This is essentially what happens between you saying something to your audio agent and your application being invoked. Okay, when we're invoked, we know we get an intent and a bunch of slots, very much like a function call and a bunch of arguments to the function call, and that somehow the speech is translated into this. A lot of people think they know how it works, but reality is a little more complicated than that, and it can often lead to misunderstanding. So I thought I answer these things all the time in the forums and on Slack, so I thought I'd actually go over it and cut a video talking about that sort of thing. So we're going to have a look at that. And I've actually prepared a few slides to kind of illustrate this. Oops. There we go. Okay. Sorry, I'm an old Lotus guy. I understand freelance PowerPoint still kind of confuses me. How do I play the slide? It should be really awesome. So many wish I really edited my videos. This sort of thing. Slide, come on, from beginning. Okay, boom, audio system, blah, blah, blah. Okay, so this is how people think it works. So up in the top, the user says something. So, I say, hello, oops. I can't draw on it, sorry. Freelance, you could draw on this screen. Okay. So, the user says something, it's like, oh my Alexa, make me a sandwich, or something like that. And the simple approach is like, oh, it hears this, it does speech to text, because everybody sees these. There's plenty of APIs and algorithms and web services that will do speech to text, converts what you say into text. Then it go and accesses your audio model, where you define all the different possible things you can say, and then based on that audio model, selects amongst the text to come up with the intents and slots that it then calls your web service with. Okay. If you were probably building something yourself, this is probably how you would build it. There's plenty of audio capture libraries, there's speech-to-text libraries, and after that point, it's just a question of parsing and matching, and you can use Yak and Lex or simply regular expressions to then work out what functionality should be called. This, however, for Alexa is not how it actually works. The downside here is that one of the fundamental rules of audio transcription, which is that the more restricted your vocabulary, the more accurate your results are. I learned this a lot doing machine translation, but it's the same dictates that apply. That if this is why when you do like a voice prompt system, which have been around far longer than audio systems, it's like press or say one. Hearing a tone is really easy, but if the user is only really going to say 1, 2, or 3. It's really easy to work out what they're saying. If you remember, for those of you old enough to remember back when these things first started coming out for your things, there was like a Dragon Simply Speaking. I forget what IBM's was called, but IBM had one as well. And the first thing you had to do was train it. You had to teach it your voice, and that upped its accuracy. It's because out of the box, it really wasn't very good. It was maybe 70% accurate, which again means for a 10-word sentence, it's got 3 words wrong, which isn't useful for a lot. So, but the idea is you add training like that, but also if you restricted the vocabulary, if it only knew that you were going to probably be saying this sort of thing, it would be great. It's like I remember I took IBM's one, and I forget what I translated. Something like, The Silmarillion or some fantasy work, and it came out with like business plan in the middle of it. And that was a pretty sort of strong heads up that the engine had been trained with, business, because IBM, they're selling to business people, probably translating or transcribing, memos and business letters. So it knew those words really well and wasn't so good at, dragons and, elves and things like that. So by restricting the domain, you get a greater accuracy. And I believe that Alexa or Amazon at the start of all this decided that quality was going to be key to acceptability. I mean, speech transcription has been around for a very long time. I mean, I'm old, and it's been around for as long as I've been around. And it's never really taken off. They put it into home, and the reason is quality is king. Okay, like I said, even if you've got like 90% accuracy, that means in a 10-word sentence, one word is wrong, and that can, kill the usability. They wanted something that was genuinely useful, not just a parlor trick. So they wanted for accuracy, and to get to accuracy, this doesn't cut it. Going from speech to text, and then using just simple pattern matching to get to your intents and slot. So this is how it actually works. And again, I have no inside knowledge. This is just my industry knowledge plus lots of watching how Alexa does things has come to this conclusion here. And we'll get to some of the people who disagree with me and stuff like that and some of their arguments in a moment. But this is, I believe, how their pipeline works. So the user says something. Now, it doesn't go straight from there to text. Okay, what it does is it converts what you said into a stream of phonemes. Okay, basically the sounds you have made. To go to text, you have to make some sort of assumptions about what they are saying. And if you know a lot of context, you can kind of make, a certain amount of assumptions, but not always. Okay. Phonemes are just rendering what was heard in a discrete way, and that's just recognition. You're not trying to put words and stuff like that together. You just sort of let, oh, that was a p, p noise, or that was an noise, that was a short o, that was a long a, or something like that, to get these phonemes with, the gaps between them and stuff like that. That also, has bearing on it. Without making any assumptions about what words they're going to be translated into. Now, push that on the stack for a moment and pause. When you create a skill, you give it an audio model. You say, okay, here's my intents, here's my slots, but then you also give it a whole list of utterance, a list of everything or likely things that are going to be said. Okay, saying, okay, when the person says, this is the intent I want, etc., etc., and in an ideal circumstance, what you give represents the totality of what a user can say. And with that, and again, this is when you hit that button and submit your thing, it kind of churns for a little bit. Well, this is what's going on there. It takes that definition you've given it and chews it all up, and essentially creates a big decision tree out of it. Okay, we'll get a little bit into decision trees in a minute there. But basically, it's a way of saying, okay, here is a way of representing the totality of what can be said. And what they can do, and again, represented as phonemes, because they can then take that text and go to the text and say, okay, how are these things usually pronounced, or what are the different alternate ways these things could be pronounced, and can work out, well, what all of this stuff should be. Now, once it has that artifact, okay, then it can take an incoming stream of phonemes and try to match it against that, okay, and there are going to be ones that are valid, there are going to be ones that are not valid. But the idea, between the difference between the two, gives them a confidence index, and then they pick the best confidence index, and they go from that to the intents and slots, okay? Because that's exactly what has constructed your decision tree, and so the output of that is that sort of result. So let me hop ahead and look at, if you're not familiar with the decision tree, and I don't even know if that's the official canonical computer science way of describing it, but it's something you use that the very early spell checkers use. So this is what I'm kind of diagramming here. So imagine, okay, you've got a stream of text, and you want to work out the correctly spelled words from the incorrectly spelled words. Well, what you do is you take the dictionary, okay, and you parse it, okay, and you create a tree out of all of the words in the dictionary. But the idea being, at the root you have, okay, what was the first letter of the word? And you have one entry for each of those. And then it's like, okay, the second tier then represents the second letter of the word. So essentially you have one root and you have all these trees spreading from that, and if it began with AA, like aardvark, that would go from the first node to the second node on the left. It was, absolute with A to the B, and whatever begins with AC or AZ, azimuth, or whatever like that. And you would fill this tree out and populate it based on your dictionary. You only have to do this once. You do this once, you create this tree, and now you're good. Okay, now I probably shouldn't put AAA there, because I don't believe there's any word that begins with AA, so that shouldn't be there and wouldn't be there. In fact, let me just hop in and take that off. Mouse to work. Boop, boop, boop. Get PowerPoint to work the way I want it to work. How do you ungroup? Ungroup. that was intuitive. Boom. Because this then becomes illustrative. Okay, so boom, we have this. What the idea is that every leaf on this tree represents a word. Okay, and I didn't draw the complete thing there, and you might have, something where like that. So the idea is that as you walk through this tree, if you get to a leaf, as you get to the end of the word in your text, then you have found a correctly spelled word. You go, okay, that's great, and you move on. If you're moving through this tree and you come to a branch that doesn't exist, like say you got AAA, with the first A sends you here, it's here, second A sends you down to here, and the third A, there isn't an entry for the third A, you now know that you have an incorrectly spelled word. Okay, and you can say, this is wrong, you need to look at this, right? This doesn't handle advanced stuff like suggesting what you should say and this, that, and the other that all modern spell checkers do. But the very early ones, like, notably spell on Unix, which probably still exists in Linux, because nothing ever goes away in Unix, is how they work. Very simple, but, again, could do this. But the key thing here is that you could take that dictionary and create this sort of tree. So bopping back to how it actually works. So you take your audio model, and from that you create all the different things that could be said, and you come up with this kind of tree of phonemes. Okay, and as you hear the phonemes from the user, you walk down the tree, and either they end in something that is, oh, yep, this is definitely what they wanted, and out of that, the output from that is the intent plus the slots, or you've just like, okay, no, this doesn't make any sense at all. Now, clearly what they're doing is more involved than that, but then so you get way past my knowledge, my industry knowledge is not that sharp. You need the real experts to tell you how we're doing, and that, of course, is going to be the real proprietary stuff, where they do a lot of stuff. This is a technique. It is used before, and this is almost certainly part of what they do, and how they convert your text into speak. Now, this is why I say to people, a perennial request has always been, please give us the raw text of what they said. Well, my argument that I've said is like, you can ask for it, they're not going to do it, because they don't have the raw text of what you said, because they go from the phonemes through this sort of tree matching thing and confidence, blah, 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 and come up with the intent plus the slots, because that's the output of the tree. What you said is not the output of the tree. Now, the counter argument to that, people have said, you don't know what you're talking about, blah, 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 based on my high school degree, I think that it works, the original way. That they must go to text first in this, because that's how all the stuff on the internet works. It's like, well, yes, but all the stuff on the internet has not produced a viable audio system. But anyhow, and it's been a point of opinion. Okay, Amazon's not gonna say it's proprietary information, and they never say anything anyway. So it's a thing of debate. However, recently I actually came across the first actual evidence to support my argument, other than industry knowledge and common sense. I was testing, this is a screenshot, this is not live. I was testing my Six Swords skill, which I've talked about before, and I was uttering the phrase, equip Mallory with ring armor. Okay? One of my companions, one of my NPCs was called Mallory, and I wanted her to wear ring armor. Now, as you can see here, I had some problems with my matching, it didn't really match it, and it's like, okay, it replied, I'm not sure who Mallory is, Hunter's care, blah, 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 like this. So you can see I actually have Mallory there. That was my problem. That's a bug in my problem, my software, which I subsequently fixed. But while I was looking and trying to work it out, it has Mallory. Okay, that is what I heard. That is what my skill was told that Alexa heard. Now, if you look down here in the voice feedback, it says equip Mallory with ring armor. Now, if you notice down here, it says Mallory, Mallorie, and Mallory. So they're different. They're homophones. I mean, Mallory, I mean, they're pretty much homophones. It's pronounced the same way, but they're spelled very different. So to all those people who say that, oh, it goes to, they have the text, why would they not give it? It's because it goes to the thing. I'd say, then why does it print up here in the companion app one spelling, and why does it return to me in my skill a different spelling? My answer is that because that's not where it comes from. That in the skill, it goes through this route here, the user speaks, it goes to the phonemes. There is never any text, okay? But that for a separate pipeline or some other process is generating the text that comes up in your card, and it is not related to what gets called and passed to your function. Maybe it's happening in parallel for speed, or, I notice there's a bit of a delay before it comes up there. on the card sometimes. That could just be latency, or it could be that it's calculating it some other way, that it wants to give you some sort of visual feedback, but it is quite clearly a different pipeline than what goes through the skill. So if you have a simple thing like this, there's no reason to give different text to your skill and different text to the screen thing. Okay, so it must be something more complicated. This is what I've suggested. This I see as supporting that. Your own opinion is going to vary. So the main output of this is, I guess, is we're probably never going to get raw text from the Alexa skill, because that's the choice they made, and it's just not really there. And if they did give it to us, it wouldn't necessarily be what was recommended. What I would really like is at the confidence level they've had, but we'll save that for another day. Now, that's Alexa. Okay, now Google works like this. Okay, user speaks, Alexa converts, or should not be Alexa, that should be Google, converts to text. The audio model looks at that text and produces intents and slots. And you're just like, hey, wait a minute, Joe, isn't this the naive slide you had for Alexa? And why? In fact, yes, it is. During the beta, I was talking to the Google people and asking them about stuff, etc., etc. And none of this is none of this. That was in confidence, but I think none of the deductions are in confidence. I don't think Google has made a secret of the fact that their approach is to produce the world-class, best possible text-to-speech engine. Okay, and that's where they have focused their energy. So by doing that, they can have a really, really top-notch speech-to-text service. Then it's just the simple matter of going against your audio model and producing intents and slots is just a simple model. They've got API.ai for that, and they also have their own thing for doing that too, and which is a more lower level thing. And they have said to me they do want to see many people use this service to do their own, audio models and their own schemas for producing audio assistants. So, it's a different philosophy and a different approach. Amazon did not pro this route because they were kind of first to market. They were really concerned with accuracy. They were creating a consumer product that had to gain acceptance from non-technical people in a domestic setting. Okay, so they're very focused on accuracy. Doing it Alexa's way is more accurate. Is going to inherently be more accurate. Doing it Google's way is going to be less accurate unless you really put a lot of work in the text-to-speech engine. Now, for Google, they're not just going to use this for the Google Home consumer device. They've got a lot of other reasons for this. Okay, they've got they've got it embedded in their phones. They've got it on different websites. They've got all of the recordings on YouTube, and if they have a good speech-to-text engine, they can go through those and automatically produce subtitles. By producing text for it, they make them all searchable. Google has a lot of uses for a speech-to-text engine that essentially, I believe, drove them to make this choice when they chose how to implement their audio pipeline. So that makes sense for Google. The way Alexa has done it makes sense for Amazon. Two different companies, two different approaches. I personally prefer Amazon's approach. I think quality really is where you want to go. But I see that Google has many incentives for making the choices they've made, so I can't really fault them on that. As things play out, it will be kind of interesting in the narrow space of audio assistants to see if, Google's, hyper-focus on speech-to-text produces kind of comparable results to Amazon's focus on accuracy of getting to your audio model. But, time will tell. And again, differences in the marketplace produce different approaches, different things you can take advantage and leverage, which is kind of nifty to see. So, that's kind of that. There's not a lot there, but I thought I would, I talked about this a lot, so I thought I would now I can put up a video and point people at the video saying, that's what I'm talking about. And I'll just leave it here with this sort of evidence of what I consider to be the nail in the coffin. There are two different approaches. Thank you for joining me.